Today we're going to learn how to compare different properties of linear functions. You should be on page 65 in your notes packet. When comparing linear functions, always write an equation to represent each function that is in the form y equals mx plus b. And we remember from before that m represents the slope and b represents the y-intercept. Once you have that equation, you can compare the slope, remember that's just another word for rate of change, and you can compare the y-intercept or the initial value, just another word for it. Example 1 shows you a table. It says the table below shows pairs of values for a linear function. A second function is represented by the equation y equals negative 3x. You have to read these very carefully so that you understand what you're being asked because there are two different functions that we're talking about here. So this table is actually function 1 because we're talking about the table first. And then it says a second function is represented by the equation y equals negative 3x. So this is function 2. Well, they actually already give us the equation for function 2, so I'm going to skip down and I'm going to put y equals negative 3x as my equation for function 2. Now what I can do is I can start comparing the functions. But remember, I don't want to compare anything until I first have my equation for each. So we need to, in order to find the equation, we need to find the slope and the y-intercept of each of these. If I start with function 1 with my table, remember that to find slope from a table, we have to find the change in y divided by the change in x. So let's look at this. If I start with my first y value and go to my second y value, to get from 6 to 5 and 1/2, I am decreasing. So I am decreasing by 1/2, which means that that is a change of negative 1/2. So my change in y, or also called my rise, is a change of negative 1/2. And this is going to look strange because we're going to have a compound or a complex fraction here, but that happens sometimes where you have fractions within fractions. Now, when x or when y went down 1/2, we need to figure out at the same time what was x doing. So x went from negative 2 to negative 1. It's easy to get confused here, but you have to remember that on a number line, negative 2 is further to the left. So negative 2 is actually smaller than negative 1. So if we went from negative 2 to negative 1, we actually increased, and we increased by a value of 1. So our change in x is a positive change of 1. Well, then all we need to do is divide. You can put this in your calculator, or you can know that anytime you divide a number by 1, you end up with the same number. So if we do negative 1/2 divided by 1, our answer is negative 1/2. That means that the slope of function 1 is negative 1/2. We also need to find the y-intercept of function 1. Well, the easiest way to do this is to look in our table. Remember that your y-intercept is going to be where x equals 0. If you look in your table, you can see if you have a place where x equals 0. Well, I see right here, x equals 0 here. When x is 0, y is 5. That means that my y-intercept is 5. I can use all of this to compare or to write an equation for my function, and I'm going to use that to then compare them. What I see is that if I write an equation, I'm going to start with y equals. Since I have a slope of negative 1/2, then I'm going to have negative 1/2 times x, since our slope is always our coefficient on x. My y-intercept is always that constant value. So since it's a positive 5, I'm going to write plus 5. So the equation that represents function 1 is y equals negative 1/2 x plus 5. Now, the only information that we had about our second function was our equation. So that was already given to us, and we can use that to figure out the rest of this. Well, the slope of function 2 is going to be the number that's the coefficient of x. So we see that x is being multiplied by negative 3, which means the slope of this function is negative 3. The y-intercept, when we look at this, we don't see that anything is being added or subtracted here. That means that this function has a y-intercept of 0 because technically we're adding 0 onto this equation, even though we don't see anything. Now we want to take all of this and we want to compare it. Well, when we compare these, we want to compare our slopes first. Well, we see that function 1 has a slope of negative 1/2, while function 2 has a slope of negative 3. Well, negative 1/2 is actually greater than negative 3. Now let's compare our y-intercepts. Function 1 has a y-intercept of 5, and function 2 has a y-intercept of 0. So we can say that those are also greater. Now also let's look at our equations. Our first equation says y equals negative 1/2 x plus 5. Well, we know that this is actually a non-proportional relationship because that plus 5 makes it non-proportional. Function 2 has an equation that says y equals negative 3x. Well, since there's nothing being added or subtracted, then this is a proportional relationship. So we can use all of this information to compare our functions. I'm going to say that both the slope and y-intercept of function 1 are greater than function 2. I am also going to say that function 1 is non-proportional and function 2 is proportional. So that is a difference that they have. Example 2 says Margaret's bank account is modeled by the following equation, where x represents the number of weeks and y represents the total account balance. So y equals 25x plus 65. So we know that Margaret's equation is y equals 25x plus 65. So we can go ahead and put that for Margaret. Jordan's bank account balances after weekly deposits are shown in the following table. So Jordan's bank account balances are in the table. Well, we need to know the equation for Jordan. So the first thing we need to do is find the slope or the rate of change. So again, we're looking for change in y, and that symbol that looks like a triangle is really a delta symbol, which means change. So this says change in y divided by change in x. So let's look at our y values. Our first y value goes from 50 to 80. Well, to get from 50 to 80, I would increase by 30. So that is a positive 30 for that change. Now, when y goes from 50 to 80, let's look at what x does. X goes from 0 to 1. Well, that is a positive increase of 1. So 30 over 1, if I divide 30 by 1, I get 30. So I know that Jordan has a slope of 30. We also want to find Jordan's y-intercept. Well, remember that the y-intercept is where x is equal to 0. Well, I can see that x has a value of 0 right here. When x is 0, y is 50. So that means that the y-intercept is 50. I'm going to take the slope and the y-intercept to write an equation for Jordan. My equation is going to start with y equals, and since the slope is 30, I'm going to say 30 times x. And since the y-intercept is positive 50, I'm going to say plus 50 for that. So the equation for Jordan is y equals 30x plus 50. Now then we have a few questions. After 1 year, how much money would Margaret and Jordan each have in their bank account? Now you have to be careful here because this is saying X represents the number of weeks. So this is asking for 1 year. Well, you need to know how many weeks are in a year. We know that 52 weeks make up 1 year. So since X represents weeks, we're going to have to plug in 52 for Margaret's equation and 52 for Jordan's equation. So for Margaret, we're going to say 25 times X, but this time X is going to be 52 since we're looking at 52 weeks. Then plus 65. Well, when we do 25 times 52, we get 1,300. And when we do that plus 65, we get 1,365. So after 1 year, Margaret would have $1,365. We'll do the same thing with Jordan. So for Jordan, we're going to plug in 52 for X. So it's going to be 30 times 52, then plus 50. Well, if we do 30 times 52, we're going to get 1,560. Then we have to add 50. 1,560 plus 50 gives us 1,610. So after 1 year, Jordan will have $1,610. Whose bank account is growing at a greater rate, and how do you know? To answer this question, if I'm looking for a greater rate, I need to look at the rate of change. Remember, rate of change is just another word for slope. So I see that Margaret has a slope of 25, which I know because 25 is being multiplied by x in her equation. I see that Jordan has a slope of 30, which we had already found. Well, since Margaret's slope is smaller than Jordan's slope, I would say that Jordan's bank account is growing at a greater rate. So I'm going to say Jordan's account is growing at a greater rate because his slope, which is also called the rate of change, is 30, while Margaret's slope is only 25. Example 3 says Heather and Damon both have summer jobs. Heather earns $11.25 per hour. The table below shows Damon's pay. I want to know who earns more per hour, how much does that person make, and I want an equation for each. Well, let's first start with Heather. So let's look at the information that we know about Heather. Heather earns $11.25 per hour. It doesn't say that Heather earns any money other than that. So we're going to have to say that Heather's equation is going to be y equals 11.25 times x. And x is going to have to represent the number of hours that Heather works. But now we need to figure out some things about Damon. Well, we need to find his rate of change. And in this case, rate of change is going to represent slope or the unit rate. And that means that is what Damon earns every hour. So to figure that out, we need to look at his table. Well, this table doesn't say X and Y, but we know that our first column represents our X values. And we know that our second column represents our Y values. Well, the first thing we need to do, because when we're finding slope, we need to find our change in y divided by our change in x. So we need to figure out what is happening on Damon's y values. Well, we see that in his first set of y values, Damon goes from $32.25 to $86. We know that that's an increase. But how much does that increase by? Well, if we subtract those, we see that we get an increase of $53.75. So if I started with $32.25 and I added $53.75, I would get $86. Now, at the same time, the hours that Damon worked increased from 3 to 8. Well, to get from 3 to 8, that's an increase of 5. So I'm going to put these into my slope formula. So my change in y was 53.75 and my change in x was 5. So I would do 53.75 divided by 5 and I would get 10.75. Well, that means that Damon earns $10.75 per hour. So let's look at that and compare it to Heather. Well, we see that Heather earns $11.25 per hour and Damon earns $10.75 per hour. So that means that Heather earns more per hour. Now, how much more does Heather make? Well, we've got to subtract because we know that Heather earns $11.25. And we know that Damon earns $10.75. So to figure out how much more she makes per hour, we're going to subtract $11.25 minus $10.75. Well, when we do that, we get 0.5. But we have to think about this in terms of money. If we get 0.5 as an answer, that is actually $0.50. So Heather makes 50 cents more than Damon. Now, an equation that represents each of these, we knew that Heather's equation was y equals 11.25x. And since Damon earns $10.75 per hour, his equation is y equals 10.75x. Now, our last question here, we've got to pay attention to. It says, will Heather and Damon ever earn the same amount of money? Why or why not? Well, because Heather earns more and because there is not a point in which they would intersect because they're changing at a different rate, they would never earn the same amount of money unless we're talking about when they both work 0 hours. If they both work 0 hours, they will both make $0. So we're going to say no, since these are both proportional relationships, the only time that they will intersect is at 0, 0, when both do not work and both do not earn money. So there will never be an amount of time other than 0 hours when they make the same amount of money. All right, let's look at example 4. The table and graph show the cost of a cab ride from 2 different companies. So you see Carl's cab service and Tony's taxi rides. We want an equation to represent each cost. Well, let's start with Carl's cab ride. Remember that our equation is in that form y equals mx plus b, so we've got to start with slope. So we know that Carl has a point right here. And then there are some points throughout here, but if we make it easy on ourselves, we can see that there's another point right here. So let's start with Carl's slope. So on a graph, remember that we use rise over run to find our slope. Well, in this case, to get from this point to this point, I would have to go up from 11 to 22. Well, if I go up from 11 to 22, and you have to be careful because it's not just counting units here, it's figuring out if I moved from 11 to 22, how far did I increase? Well, I increased by 11, so that's going to be a positive 11. And then to get from this point to this point, I would have started at 0 on my x, and I would have ended up at 10. So I had an increase because I went right from 0 to 10, and that is 10. So the slope for Carl is 11/10. Now, we also need the y-intercept. So remember, a y-intercept is where you intersect the y-axis. So your vertical axis is your y-axis. And you can see that this graph has an intersection of the y-axis right here at 11. So that means that the y-intercept is 11. Well, if we use that to write an equation, our equation is going to be y equals 11 tenths times x plus 11. So 11 tenths, because that's the slope, times our x. And then our y-intercept is positive 11, so I put plus 11. Now, when we think about this, whenever we're graphing, we know that we always want to have a fractional value as our slope. However, in this particular instance, it's actually going to be easier for us to deal with a decimal because we're talking about costs. So we can take 11 tenths and we can turn that into a decimal by doing 11 divided by 10. If we do 11 divided by 10, we get 1.1x plus 11. And 1.1 is going to represent the cost that we pay for each mile because x represents the number of miles. So for Carl's cab service, our equation is going to be y equals 1.1x plus 11. Now let's do the same thing, but for Tony's taxi ride. So remember, distance is our x values and cost is our y values. So the first thing we want to see is our slope. So we're looking for change in y divided by change in x. Well, our y values go from 1425 to 1925. That's an increase of 5. Our x values go from 5 to 9. So that's an increase of 4. So as slope, this would be change in y is positive 5 and change in x is positive 4. So we would have 5/4 as our slope. Now we've got to figure out the y-intercept. And if you look, we don't have any values in our table where x is 0. That doesn't necessarily mean that our equation is just y equals 5/4 times x. And in fact, you can try that out because your first x value is 5. And if I did 5/4 times 5, I would get 25/4, which would simplify, if I simplified that, to 6.25. So I would get a y value of 6.25 here. But if you look, when x is 5, I'm not supposed to get 6.25. I'm supposed to get 14.25. So what do I do? Well, at this point, I need to ask myself, what would I do to 6.25 to get to 14.25? We know that our slope is correct, but we know that we have to either add or subtract something here so that we can get 14.25 as our y value. Since we plugged in 5 for x and we got 6.25, the question is, what do I do? I would add 8 because if I have 6.25 and I add 8, I'm going to get 14.25. And that is what I know I should get for my y value. So I'm going to add 8 here. And now I can see that my y-intercept is 8. Now, again, for Tony, because we're talking about money here, I probably would not leave 5/4 as a fraction. And instead, I would change 5/4 into a decimal by doing 5 divided by 4. And 5 divided by 4 is going to give me 1.25. So I have 1.25 times x and then plus 8 for my y-intercept. Which cab company has a greater rate of change? Well, I see that Carl's cab company has a rate of change of 1.1, and Tony's cab company or taxi has a rate of change of 1.25. So that means that Tony has a greater rate of change. How much is that rate of change? It's 1.25 or $1.25. So in this situation, it means that Tony charges $1.25 for each mile. And because his y-intercept was 8, that meant that at 8 that he charged a flat fee of $8. The last question here says, for how many miles will the cost be the same at both companies? Well, if we're doing this, we actually have to set up an equation. And I want to know, when will this equal this? So I'm going to write an equation that says 1.1x plus 11, since that's what Carl charges, equals 1.25x plus 8, since that's what Tony charges. Well, then I'm just solving an equation. Now, remember, when we have an equation that has a variable, so we have the same variable x on both sides, I want to move them so they are on the same side. So since 1.25 is bigger, I'm going to move 1.1. And since it's a positive 1.1, the inverse of that is subtracting 1.1x from both sides of this equation. 1.1x minus 1.1x is 0, so these will cancel, and I'm bringing down positive 11. On this side, I have 1.25x minus 1.1x, which gives me 0.15x. I also have plus 8 over here that I haven't done anything with, so I need to bring it down. Now we have just a regular two-step equation, and now we need to get x by itself. So we need to get rid of our plus 8 first. So we are going to subtract 8 from both sides of this equation. 11 minus 8 is 3. And then our 8's over here will cancel, and we're left with 0.15x. Our last step is to get x by itself. Well, we need to get rid of 0.15, so we need to do the inverse, which is dividing by 0.15 on both sides of this equation. 3 divided by 0.15 is 20. These cancel to leave us with x. So that means that these two values, or these two companies, are equal to each other when x is 20. That means that they have the same cost when they have a distance of 20 miles.